The last set of material for Matlab is to go over plotting, and this is where Matlab is really great. Not many other languages have such nice plotting capabilities as easily accessible. So there are lots of plotting functions in Matlab. There's a whole table of them here. We are going to focus on plot, fplot, and the semi-log ones, or the log ones. Okay, we're not really going to get into the rest of them. If you know one, you can kind of get an idea about how to use the others. I'm going to jump around in the notes a little bit, but I'm going to go down to this section. So here is a description of all the plotting functions that we're going to talk about. So the first one is just the plot function. Here's a hyperlink to the Matlab documentation, but it just tells you it's used to create a line graph where a straight line is used to connect data points. So it literally draws a point, a point, a point, a point, a point, and it connects straight lines in between them. So the more lines you have, or the more dots you have, the more points you're plotting, the smoother the curve is going to be. So there's a couple ways to use it. You can just say plot y, where y is a vector of data. If it's a matrix of data, it will plot each column separately. But it just plots the single vector values versus the index. So the index being 1, 2, 3, 4, 5, and then whatever your y value is, and connects the lines between them. If you say plot xy, then it's going to create an x and y vector. They're the same size, where each data point is the x, y component. So x1, y1, x2, y2, x3, y3, etc. Plots them element by element. That's one set. Once again, if y is a matrix, it will plot x versus every column in y. We can also plot more than one set of data using this option. So plot x1, y1, so this is say 1, sorry. X1, y1, so it plots that set of data as the first line. Then it plots x2, y2 as the second set of data, so it draws a second set of lines wherever it is for your second set, and then you can repeat for as many sets as you have. Keep in mind, x and y vectors must be the same length. The next function is fplot that we'll go over. Fplot is a specific kind of plotting function that can only be used for a defined mathematical function that's defined as y equals something. And it's got to be with one independent variable. So it's limited. It's not overly useful, just going through how to do it. So if you're plotting y equals x squared, we can easily plot it with fplot, where we would say fplot, and then we'd have the at symbol, and the inside is x. This is our independent variable. So here is our independent variable. And then we list out our function. So x squared, this needs to be written using element by element notation. And if you don't, Matlab will yell at you. And then we just list out the limits. So what is our x min and what is our x max? And then we're done. So let's say we want to plot it from -10 to 10. It would plot x squared from -10 to 10. So the nice thing about fplot is that it eliminates the need to create a separate x and y vector that you would need to do plot up here. Really, you're just reducing 2 lines of code. And then it's adaptive. It makes a smooth curve. It enforces a smooth curve when it's used. But once again, it's very limited. You need to have y equals something in terms of one independent variable. And the last 3 to talk about are semilog x, semilog y, and log. These are used for logarithmic data. And you can plot it where it's logs on both. So log is plots x and y data, both of them, the logarithmic axis. Semilog x has a log scale on the x-axis. Semilog y has log scale on the y-axis. But all 3 of these behave exactly the way that plot behaves. Keep in mind, there is no log of a number 0 or less than 0, so you can't plot anything less than or equal to 0 on a log scale. Those are the functions we are going to focus on. I will go over examples in more videos.